Good morning, friends. This is Durga from IT Varsity. So the guy who will be hosting will be joining very soon, and then we'll get started. So meanwhile, I will give brief overview about what today's agenda is. Today we'll be focusing on about what is cloud, and also we will try to explain what our roadmap is with respect to cloud. And also towards the end, we will talk about a little bit on AWS. And also, if you want to get periodic updates, uh, towards the end of the page, which you are seeing here, I will be adding it to the description of the video, and also I will be pasting in the chat. Okay, so this is the URL for the content of today's agenda, and I will be adding to the chat also. Yeah, it's already in the sorry, I will be adding to the description. It is already in the description. You can click on this link in the description anytime after the session, and you can actually sign up for the newsletter. Okay, so until then, let us wait to the actual host. His name is Kishore. He will introduce himself, and then we'll get started. Okay, let me share my screen. Actually, I already shared my screen, but still, okay, I'm sharing my screen now. Now you will be able to see my screen. Okay, so I'm waiting for Kishore to join. Okay, so once he is in, I will actually hand over to him. So let me send him invite, and then I will start sharing my screen again. I am stopping sharing for now. I'll be starting sharing once he join. Okay. Okay, just bear with me for a couple of minutes, and we'll get started. Sure, Pramod, thank you very much. We will not only cover AWS, we will cover few lot of other stuff also. So today's discussion will be primarily on public cloud. We are also forming a team to perform R&D on private cloud. Starting from Linux, we will be focusing on OpenStack and many other technologies. Hey Kishore, can you hear me? Uh, okay, let me see how to make you a presenter. I don't know how to see you. Here it is group chat. I thought I will be able to add you to this. Okay, let me do one thing. I'm not sure how to add you to this. Okay, let me do one thing, Kishore. Kishore, you actually have control to this. So what you have to do is um, you you go to okay. What you are supposed to do is go to the channel. Go to the channel like this. So you already the manager or admin for this channel, and then go to Creator Studio, and then as part of the live streaming, you will see events. Okay, in that you have uh, this cloud and AWS announcement. Okay, you just click on that, and then join. Uh, uh, Probably that might let you to share the screen and all. Okay, try that. Just give me a moment, guys. This is the first time we are actually trying out with YouTube Live with the two speakers. That's where the confusion is. I'm keeping you guys on mute for a minute.
Hello, hey Durga, can you hear me? Hello, hey Durga, can you hear me? Right. Sorry, guys. I think this got delayed due to some technical issues and some time zone confusions. But yes, so we are live now. Right. I think this got delayed due to. Right. Okay, so I'm sure Durga has probably given you guys some overview of what we are planning for. So I'm going to just take over and talk about the roadmap for our cloud initiative that we've been planning for a couple of months now. So the idea is, again, what the reason why the IT University has started open source training. We are now adding the cloud. Give me 1 second. I'm sorry if you guys are hearing me, but I think there's an issue with there's still an issue with the Hangouts, the way we're doing the YouTube live streaming. So we're gonna switch to WebEx. Just wait for the invite from Durga.
First, you have to share your screen by clicking on this.
Hey, Durga, can you hear me?
Yeah, I can hear you. You can start.
All right, sounds good. I'm going to restart. I'm not sure, how much, you guys heard me before. So the idea is again. I'm going to restart. Not sure how much, okay. I think we're all set now. Okay, so we're going to start the cloud training program, starting with the public cloud. Basically, a lot of cloud providers, as you guys know, but we're going to focus.
Teacher.
Let me do one more check. Durga, is it all right now? Okay, I'm not hearing anything back, so I'm assuming it's everything is all set. All right, sorry guys. This is my first time doing all this live streaming. All right, forgot to do my screen sharing. Let me share my screen. All right, done. All right. Okay, let me restart it again. So I think you guys have been following ITversity for a long time now on the big data content, and we are adding the cloud content to the same platform. And the roadmap, I'm going to go over the roadmap very soon, but the idea is again start with the public cloud providers, which is quite popular audience, right? We are familiar with AWS, we're familiar with Google Cloud and Microsoft Azure, and we're going to start with other cloud providers later on. But to begin with, we are focusing on the AWS, and we're going to follow the same model that we follow for the big data. We'll have a fundamental AWS fundamentals videos, and then all the certification tracks. There's sysadmin certification track, there's DevOps certification track, and there is an architect level certification track, which there'll be all these tracks that will help you to learn the technologies and the skills that needed to give the certification from the Amazon. And there'll be labs too. And I'm sorry, I should have introduced in the very beginning, and with all the technical glitches, I forgot to. For the people who don't know me, my name is Kishore, and I've been working on this, administration, cloud, DevOps, all the different names to these technologies, right? For past 10 years now, and currently based out of Bay Area. And I've been doing this for 10 years now. As I said, worked on different public cloud providers, private cloud or open source cloud like OpenStack, containers, DevOps, and in this field for long now. So I'm going to share my experience, things that I've learned, things that are important for everyone to learn through ITversity, and I hope everyone will learn the cloud things from ITversity. I'm sorry, I'm going back to my roadmap again. So yes, there will be certification tracks, not just the theoretical content. There'll be labs too. So there'll be videos that explains how to practice this. It could be creating the compute nodes on the Amazon, right? Creating the storage piece on the Amazon, creating the DNS entries on the Amazon, the network layer on the Amazon. There are different pieces in Amazon, and we'll get to the details in the videos. But everything will be, you can practice it by following the videos. But unfortunately, it's not an open source thing that where we can provide you an easy way to train. So everybody has to have their own Amazon account that they can use for the training. But the good thing is Amazon and any of the public cloud providers has a this free tier structure, which means they have a limited resources for everyone to use for free, which is more than enough for us to loan this cloud providers, right? Let me show you what we can talk about. Just all right. Let me open up. I don't remember this limit on top. They keep changing. So this is the AWS free tier, right? So you can go to Amazon, aws.amazon.com, sign up for an account. Let me show you what
Hey Kishore,
talk about.
Kishore, just a moment. We will go to AWS a little bit later. Can
On top, they keep changing. So this is the AWS free tier, right? So All right, let me share my screen here. All right. Okay. So let me explain, right, before we get into demo and all those details. That I would like to have me explain what we giving guys a preview of what cloud is, what are the different forms of cloud, what is out there, and what should we focus on, right? So basically, I think you might have heard the name called cloud. It's kind of fizzy, but cloud has different meanings, right? But what we are focusing on is basically the word called cloud computing, where you are renting or getting the services on demand delivery of compute power, you name it, storage, network, any IT resources through the cloud services platform via internet, right? Uh, Previously, as we all are familiar with, when we have to operate on infrastructure, when we have to install, run any applications, we used to buy servers, put them on a rack, put them in a data center, install OS, and then do all the other stuff on top of it, right? Which takes a long time. So if I have to application and have to take it live, there's a lot of this back end work that needs to be done. So there's a lot of lead time. So to avoid all this, now you can just rent the infrastructure within a minute from one of these cloud providers, right? It's just made it so easy for anyone to build their own applications, everyone to build their own infrastructure or the platform, right? So here is a diagram. System has been evolved. I was just talked about the hosting model where you have your own servers, and then you install the OS, you rack the servers, you maintain those servers in your own data centers or the lease space in the data centers. And then there's this applications became a service and the hardware has been grown, right? So what was the traditional problem with the hardware is basically you have a big server where you only use 10 or 20% of it, or rest is being is called idle resources, right? There's a lot of this ideal computing power, computing or infrastructure resources that's been just idle in the ideal and not being effectively used for any of the purposes. So there's been a huge concept called virtualization where you can build multiple VMs on the same server, where it also solved the problem of instead of you building 10 servers in one rack, you can have one big server and run hundreds of VMs on top of it, right? It's just improved the amount of hardware you can store on one single server, and it gives you the benefit of launching hundreds of isolated instances or isolated servers on the same physical machine. Virtualization actually has helped us in a lot of different ways. It's a huge success for a lot of companies, which is why VMware has become such a big company today, right? But there is some overhead on top of VMware, and there's some limitations with the way that people have been using VMware, right? Which is where we moved into software as service for a different reason, where you don't want to manage any software on your own servers. You can rent the software, which is hosted on different third-party vendors. You're just paying a subscription to them to just use their software, and you don't worry about managing or maintaining anything, right? For example, there is Salesforce, which is a pioneer in this space, where they have CRM as a service, where people can just use their software, which is on their cloud or on their servers, just pay for the software, right? Nothing, no hardware, no infrastructure to manage. But that's only for the software companies to provide the software as service. But now there's a bigger need for cloud for everyone, for other purposes, right? Not just software service, but if you, for your own purposes, for your own software development purposes, the cloud has changed many things. As I just, there's an infrastructure that you have to manage, and all that headache has gone. The complexity of managing and building this infrastructure has gone, because now it's been managed by a company that you're just paying money to rent this infrastructure, and you're not owning anything anymore. Which is where this Amazon came in. Now there's Google Cloud, this I guess IBM Cloud too, and there's Microsoft Azure and many other players in that, rack space and restaurant players. And basically the concept is again the same, right? For you to bring or for you to host your application or your infrastructure or anything, it only takes an API call or 2 API calls to bring your infrastructure live, right? And that's it. You're not buying anything. You're not managing any infrastructure. So, right, we talked about software service. So we talked about software service, right? I'm going to just introduce 2 more things, which actually has the next steps of the evolution of software service, right? There's a platform as service. Basically, software service is like, if you're familiar with Zendesk or Google Apps, it's a software that's giving you as a service, right? Not the infrastructure, not the platform. All you're paying is only for the software, which could be a Dropbox or Google Apps thing where you're paying a certain amount of money for them to store your files, or do some online doc edits and all that stuff. But the platform as service is the next step, where it benefits basically the broader software development world, right? Rather than just the software being developed or being delivered over the web, it's just a platform for you to create the infrastructure and the software that you want. Heroku is a big player, right? They'll give you a platform as service where you just deploy your application, and everything else that's needed for your application is being provided by the Heroku, all the platform. Could be app servers, could be database layers, anything. You just tell them that this is what I need for my application to run, and they will provision that for you, which means you are less worried about maintaining the platform that is needed to run your software, right? Which is where the Cloud Foundry has came in. The Google App Engine is there. As basically it's giving power to the developers to bring their application live, instead of waiting for a big operations group to manage and build the infrastructure, right? If I'm a software developer, if I can write the code, I can host it anywhere that I want, and I don't have to worry about managing and complexity of the infrastructure of the platform. And the next step is basically the infrastructure service, right? Take that away platform and even give you the basic skeleton to build whatever you want. Now I'm just giving you a infrastructure, which could be the Unix servers, or basically Windows or any servers in the compute layer, storage, networking, different OS, different operating systems. Everything has a different pieces that allowing you to do whatever you want, right? I can build anything on my infrastructure. I will rent a compute node from one of the cloud providers, and I can use it for building my app server or building my database server, building a cache layer, anything that I want. And I don't have to worry about, again, managing the underlying infrastructure, right? If you guys are familiar managing the whole network layer, could be firewalls, could be, from layer 3 to layer 7, how do you make sure that they communicate in a proper subnets and all that stuff? It was very complex. Not anymore with this cloud providers providing you the service to just build all these things just with 1 or 2 API calls, right? And that's where the infrastructure service, that's where the Amazon Web Services has become a pioneer, and now everybody is following them, which is the Microsoft Azure, Google Cloud, there's DigitalOcean, Rackspace. I'm not sure if they're still in the, but the Rackspace is also one of the public cloud providers now. So we're talking about public cloud for a while now, and if you're wondering what is public cloud and what is private cloud, right? Basically public cloud is defined as multi-tenant environment, which means it's not dedicated just for you. whatever you're buying, whatever you are getting from these cloud providers for the money that you're paying is for you, but the underlying infrastructure, the underlying hardware, underlying network component that are used to power your infrastructure is not just dedicated for you. For example, if you go back to our VM concept where there's just one big physical server and there are multiple VMs running on it, it's the same thing, right? You're renting one of those VMs from one of these cloud providers, not the entire big hardware server. The VM that's running on the same server can be rented by somebody else. So it's basically, if I need a certain instance size, certain server size, the size of 32 gig RAM, 16 CPUs, and with a 2 gig network card, that's all I care about, right? I want them isolated. I don't want anybody else to use my network resources or my hardware or memory resources, and that's all you're asking for, right? And Amazon will give you, or one of these cloud providers will give you that resources, and they have their own naming conventions, right? I need C3x large or 2x large by Amazon, or I need this much size of the instance on this cloud provider, and you'll get that. But there are neighbors sitting on the same physical server, sharing the same RAM, but a part of it with a pure isolation, but they're still running on the same server. It's a multi-tenant environment. It's not dedicated for you. That's what is a public cloud, right? It's purely opposite to it. Private cloud is, it's exactly the same benefits of cloud. Everything can be provisioned with by making API calls or by using CLI from the command line, right? But it's basically not shared with any other users or any other organizations. This could be sitting in your data center on your servers, but then build the servers, build the network layer, build the storage layer, just the same way as the public cloud. For example, OpenStack, right? It's an open source software that you can use to build your own private cloud. Again, the private cloud is basically it. All the servers are owned by you. All the servers are dedicated for you, and you can do whatever you want with those servers, right? So I can launch 2 smaller instances on one, or even 10 if it supports that. Or same thing with the storage, right? I can just give a person in my company to use 100 gig of storage on this, or 1 terabyte of storage, and it's all provisioned on demand. So the concept is still same, but the infrastructure is dedicated. That's the only difference between the big difference between public cloud and private cloud, right? So there are advantages with the private cloud. There are certain companies like financial companies, for example, like banks, anyone that they don't like to share or be on a public cloud because their data is so confidential. Um, um, they're afraid that their data gets stolen. It's all valid. I'm saying valid fear though. So, which is why they still want to operate in a traditional way, but they know all the lead time to take build the server, put them in a rack, put them in a data center. It takes a month or 2 for them to add 2 more servers into infrastructure, which is why they are private cloud environment where they have a bunch of infra servers ready to operate as a private cloud for their own applications. And the advantages are basically privacy, right? And it's important for certain companies. And this hybrid cloud mix of both public and private cloud, right? Some part of your infrastructure. Let's say if I have an application, let's say if I have an e-commerce application, and there is certain data which could be the products data, and there's certain data which is credit card information data of my users. And I definitely don't want to store this credit card information on a public cloud, right? For different reasons. I'm just not happy with storing it on a multi-tenant environment. So in that case, I can build my infrastructure in a way where now whatever information I'm okay with the product listings, all this data servers, or the resources needed to power that part of application in the public cloud, which is one of the cloud providers, right? Amazon, Google, Microsoft. And then rest is on my own servers. And I can connect this public cloud to my private cloud using different networking mechanisms. And we'll get to that in when we actually talk about the different ways that you can build a hybrid cloud in later videos. But that's a concept, right? You're bringing the power of both privacy and the on-demand public cloud, which is somebody else is managing for you, which you can just rent it as on-demand basis. So you're just bringing those two and calling it the hybrid cloud, which is where I think most of the companies are going with, because there are advantages with going with public cloud route, and there is a need for private cloud. So both the advantages and need are getting satisfied with the model of hybrid cloud. And that's the different types of cloud environments that you'll often hear or you'll often work on, right? So let's and then that's pretty much about the cloud. If there are questions, we'll take them in a bit. But then, I think we're getting to our track, which we are trying to build now, is basically the cloud and DevOps stream, right? So DevOps is, again, a mixed term, right? There are a lot of different ways that people call themselves as a DevOps. Even every company has their own definition for DevOps. So, and the reason why we use the DevOps is, again, it's the same reason. In DevOps, it's not just one technology like cloud. It's a practice, and we will try to focus most on most of the most commonly used or popular technologies. Could be containers, it could be Puppet or Ansible, right? Technologies that the DevOps people are using in their day-to-day life. But the focus is we're going to start with cloud. That too, we're going to start with public cloud and the Amazon to begin with. And here are the, if you're seeing my screen, here's the list of things that we're going to focus on. There's AWS fundamentals. That's basically introducing you the Amazon. What are the different things that Amazon will provide? When I say Amazon, it's basically Amazon Web Services. Sorry, but Amazon has many other different products, but we're just talking about the AWS piece, right? What does the AWS gives you? What all you can do on AWS, right? We'll talk about all the fundamental things that you need to know before you go to any, before you start looking at any of our certification tracks. And on going to certification tracks, the SysOps admin associate, and the same thing with the solutions architect, and they both have the advanced level certification tracks, which is the professional level for architect and DevOps engineer. And there is a AWS developer, which is basically, if you're not an operations person, if you're not a DevOps person, if you're a pure developer and you still want to use AWS, there's a certification track for them, and we're going to focus on that too. Basically, right, as a developer, as a programmer, how can I use Amazon to build my applications, the applications that I want? It could be web applications, it could be mobile apps. How can I build? What are the technologies that Amazon provides for me? And how can I bring it live, right? So those are the things that we talk about. And once you're done with AWS, we're going to go with the next ones, which is Azure or Google Cloud, and we will announce them as we make more progress in this certification tracks. So that's pretty much it. And let me see if there are any questions that I should take. Duga, are there any questions? Let me just look at the live chat. All right, we'll go ahead with the demo. If you have any questions, just use the chat session, and then we'll try to answer them at the end of the session. Okay, so there's a question here. Question from Abdul. I'm repeating the question here so that everyone is on the same page. So I'm a Hadoop admin and I don't have full knowledge on any programming language. Which language I have to learn so that I can take up DevOps associate certification? It's a good question. So basically, none of this really ask you to learn any programming languages. Basically, if you want to just get the certification, But what I recommend for anyone who's looking at the DevOps career is basically shell scripting is no more. I think should stop calling it as a programming language anymore or scripting language. It's been old school with the servers and everything, and there's still shell scripts out there that people still use it. But I think pretty much the world is moving towards software programming languages and using them for system administration purpose. Where previously there's shell scripting just for system admins, right? Not anymore. Python is a good choice. Very widely used, not just for your system administration or DevOps purpose, but I think could be in general for a programming purpose, right? And AWS has a really good support for Python. In fact, they have support for every language out there. Could be Java, could be Ruby, and everything, right? But I think Python in general is widely used in DevOps area. But if you are asking me if I should learn Python to get certified in one of these associate tracks, you don't have to, right? If you're looking at the one of the SysOps or DevOps, basically this is the concept here on the certification track is only focusing on the AWS technologies, right? The questions like or things like how do I do this on Amazon, right? How do I build servers for fault tolerance, right? Or it's basically covering the Amazon's concept. They're not going to ask you to write any code anywhere, right? Because Amazon has many tools to be a DevOps engineer on the AWS cloud. Some of them are AWS CLI, right? The AWS CLI is a really good tool that you can use to automate pretty much a lot of these things. They have CloudFormation, they have OpsWorks, they have I think it's Beanstalk, if I remember it right. So they have all these DevOps tools. They call it DevOps tools just because they empower DevOps people to manage and automate most of the AWS day-to-day things. So you really don't have to learn Python to get certified, but learning Python will really help you in long term. So you should start learning it in parallel because it's not going to harm you. It will definitely help you in long term, but definitely not needed for this certification. There's another question from Pramod. Where does HP Enterprise come in? Good question. Let me think. HP has different things. I don't think, or at least I'm not. I haven't heard of any cloud products from HP yet. I know they have physical servers. They used to have. I think they still have. Or even now, a lot of people still buy servers. The physical servers that you buy and you use it for your own purpose, right? That you are actually putting them on your rack on a data center. You had put the network connectivity on it. The physical servers, there are HP that actually build a lot of enterprise servers. Actually, some really good servers that they build that you can buy from them that you can use to build your infrastructure. But of any cloud solutions from HP yet. If there is one, I'm not sure, but it's not that famous, or it's not. At least I'm not familiar with it. So. Pramod, I hope I answered your question. If not, just post it back on the chat if you have follow-up questions. And there's one more question from Muni. We can use CLI as well as API, right? That's right. Which is the programming language that is most used? Good question. So for CLI, basically, right, you don't need any other additional programming languages, right? You just have to install AWS CLI on the server that you're using. There's a package that they have based on the operating system that you're going to install it on. They have it for your laptops like Mac. I'm sure they have it for Windows as well. You can have it installed on Linux or Ubuntu or on these servers. Wherever you want to run AWS CLI commands, you need to install the AWS CLI software. That's it, right? There's no programming language inside it. It's all pretty much, if you are familiar with using Linux command line, like LSCD and all those stuff. It's pretty similar to that. They have really good helper module that you can really follow through. There are manuals that you can use to learn and how to use AWS CLI. So basically, AWS CLI is like another command line, right? You can use any programming language to make use of AWS CLI and to do a bunch of things. For example, if I take shell scripting, which is still the easiest one, right? I can write a shell script that can use AWS CLI to do multiple things. For example, I can actually launch a server using AWS CLI, and then in the same shell script, I can look for the status and then say I'm done with it, right? So I can still use any programming language. Could be Python, could be Ruby, and then use AWS CLI inside it. Because when you're using any of this, if you're using shell scripting, it doesn't have a native support to AWS. What I mean by that is your shell scripting cannot talk to Amazon. It doesn't understand the same language, which is why you're using AWS CLI. CLI, most of the things that it does for you is that Amazon can understand in the backend, right? They talk the same. They talk the same language. If you are using any of the programming languages, let's keep the shell scripting for a side now, where you can talk to the API directly, which is where you're talking about. That you can use any programming language. Every programming API is very generic, right? There's no programming specific API. API calls can be made. There's an endpoint. There's a way to you call an API. You can use any programming language. It boils down to what programming language you are comfortable with. You can use Python. You can use Ruby to call API. There's another way, which is basically the AWS will provide you the SDKs, which are called the software development kits. Right? There's a Java SDK. There is a Python. There's a Python library. There's a library called Boto. It's a BOTO. And if you are very familiar with Python programming language, you can use a library called Boto that can talk the language that Amazon understands. Like I can use Boto library and say I want this many instances of this size in a Python programming language, and it can launch those servers for you. And you can do pretty much everything that the Amazon can natively do from the console or from CLI. And similarly, there's a gem for Ruby. Everyone has their own languages, right? So in Ruby, they call gem. AWS has a gem that you can use. So your Ruby can talk to AWS using that gem. Similarly, they have support for every software, for PHP, for Java, for Ruby, for Python. I'm sure many other languages too, but these are the most popular that I am aware of. So the choice is the most comfortable language that you're with. And there's another choice where you don't have to use any programming language and just start using the tools that Amazon provides you, right? Like CloudFormation. It's all there are JSON templates. Now I think they just recently started supporting YAML files. So the different configuration files that you start, and then you use Amazon CloudFormation to build your infrastructure. There's no programming language there. There's a programming concept, but in a different way. You don't have to learn any language. So there are many choices, but the advantage. Okay, let me just try to keep it short. The advantages is basically if you use a programming language, today you can work with Amazon. Tomorrow you can work with any other cloud provider or using your own OpenStack or something. If you start using CloudFormation, you're tied to Amazon. Tomorrow, if you have to move to Azure, or if you have to start working on Azure on a different project or at a different company or even at your own company, then you cannot reuse the CloudFormation to bring your infrastructure on. It's very much tied to AWS, right? So that's the pros and cons, right? And there are many more, and we'll go over them in the cloud videos, but this is just one example. So picking any programming language upfront will actually help you to do things better and actually support many other cloud providers. And there are very generic tools too, like Ansible, Puppet, Chef that you can use to bring infrastructure on any of these cloud providers. And hopefully, I think we'll have the separate track to cover those tools that you can use to manage these cloud providers, and we'll have it later. Just a follow-up comment. Let me just quickly take this and we'll go back to our demo page. That's from Pramod and said, I have seen posts that they're getting into hybrid cloud with Azure recently. Yes, it just, I think you probably read it right. So the Amazon is way ahead of any other cloud provider. It's just they started it early, and they were the pioneer, right? I mean, it's just people are, and there's a lot of ease in using Amazon. It's just a one in the market advantage, right? And there's Google Cloud and Microsoft, which have started late in the game, and they're trying to go do a catch-up game now. So Azure is actually doing a lot of good things to capture a different market, which Amazon is not been focusing so far. This is actually supporting private cloud and hybrid cloud environments. So one of the things I heard, I haven't used that feature yet, but one of the things I heard that I've seen is basically if you have an OpenStack environment, that they can support OpenStack environment on the Google Cloud, basically giving you both the ability to have a private cloud and public cloud just using Microsoft Azure. It's an amazing concept, but in reality, I'm not sure how they're doing it, because even Amazon is now giving a dedicated service, which is, you can call it private cloud, but they have a lot of condition supply thing, right? If the server is gone, you won't get it. You will have some, you will lose some of the abilities that you can launch one more. There's something called auto scaling, that you lose all those auto scaling and elastic scaling features if you go with dedicated. But Microsoft is solving that problem in a different way. So I think even I'm waiting to see it. How they're going to solve that problem. I think those pretty much the questions for now. All right, so we'll get into the demo, and we'll take those questions later too. So let's just do the AWS demo for now. So basically, right, what do you do when you go on Amazon, right? What do you use it the AWS for? Basically, there are different things that you can rent or you can actually get from AWS. Right? There is computing, which is called EC2. Basically, right, whenever you see E in AWS terminology, it's elastic. That's it. So it's elastic computing. It's a CPU and RAM. It's basically a server that you get. And for example, if you have a high computing needs, which is if your application is CPU intensive, which means you need more CPUs than memory, they have a different. They call it instance family. So they have a C family, which is compute family. If you have more memory needs, which means, hey, my server, I need more memory. Could be I need 128 gig memory, and I don't need too many CPUs. I'm fine with 8 CPUs, right? And they call it M family. Right? Memory optimized. There's compute optimized. There's resource optimized, which is both memory and CPU in a much better ratio, right? So it's up to you to choose the right instance size. And basically, I think once you start using it, there are different use cases. For example, if you're running any of the databases or any of the cache layers, you need more memory. So, and the concept here is basically you are paying for the resources that you're renting. For example, if you're renting a server with 128 gig and 16 core CPU, you're paying for all of those resources. But if your application only needs 32 gig of RAM and only 2 CPUs, you don't have to rent additional memory or additional CPU because you're paying for it, right? You have to add some buffer, but you can actually go a much smaller size and only pay for that, which is why there's a lot of flexibility on it, right? And changing those instance size, moving from one to other, they're all pretty seamless. Right, you don't lose anything on it as long as you're using certain storage types on the server, and we'll get to the details later. But that's the concept that they have, right? There are a lot of benefits with EC2. As I just said, you can increase and decrease the instance size. What I mean by size is basically you can add You can go from one size of instance, which means you can expand or decrease the capacity within minutes, and pretty seamless, right? You can just use the same CLI or same a couple of API calls to just say, hey, from this instance size to much bigger or much smaller, and you can do it pretty seamless using the same automation tool, and it's all taken care by Amazon on the back end. You don't have to worry about it. For example, if you have to do it on your own on your own servers, it's much bigger exercise. You have to buy another servers, put them in a rack. You just have to bring that application back up, migrate all the data, and then shut this down. There's a lot of big process, right? And it's all actually taken care of by Amazon in the backend for you. So it's completely controlled, which means you're not maintaining anything. For example, there are certain RAM modules, right? If there's a 32 gig server, it could have 4 8 gig RAM modules. It's basically similar to your laptop, right? There could be different RAMs. It's a RAM failure in a traditional world. You have to call a data center guy, go pull that bad RAM out, or pull the bad CPU out, or the motherboard, or the power unit. Most of this, any failures, anything that happens on the instance, or any management that you have to do on these servers, there's a long and lengthy process in the traditional world, right? In the cloud world, it's all taken care by the Amazon or by the cloud provider, right? It's a zero maintenance. It's completely controlled if you do it right. And the advantage here is the CPU or the EC2 layer is actually basically integrated with a lot of other Amazon services. For example, if I have to use a lot of storage from this server, and I can put it into their, they have different storage systems. I can attach a bigger disk that I want. I can remove the bigger disk and just put the smaller disk on the server, or I can just put all the storage into S3 directly from the server, right? You can write to S3 directly, or you can use any of their other services, right? Their load balancer service, their DNS service. Everything is well integrated because it's all Amazon's a complete infrastructure service solution. So, and very reliable. Unless there are bigger issues like which probably have heard on the web, you probably have read recently that they've been having some network issues or power failures or outages in the data centers. And they do happen, but in general, compared to the managing your own servers and data centers, I think any of these cloud providers actually do a really good job of giving you a reliable infrastructure because they have a built-in fault tolerance. For example, if your EC2 instance has a problem, they'll bring a new EC2 instance for you and then replace it in the backend. If there's underlying host problem, for example, the physical server where your I would say VM is running has a problem, they will move your EC2 instance onto a different infrastructure altogether. So there's a lot of magic that happens on the backend that you don't have to worry about, don't have to deal at all. Which means, right, less people to manage your infrastructure, less things to worry about, or actually you can focus on actually building the application and doing better things rather than worrying about all these smaller issues. And I think the bigger benefit more than anything is easy to start, right? For me to, if I have to build 1,000 servers today in a data center, it will take me a few months or a few weeks, right? Depends on a lot of things. But the same thing is few minutes here, right? I can just go create an account, or if I already have an account, I run a script, or I use a CLI or anything else, or even go to console and say, I need 1,000 of these servers of this type, and it will launch them in minutes. So that's the beauty of the cloud, right? It's all there. You just have to pay them the money, right? So that's the EC2 layer, and then there's the storage part of it. There are different storage options, right? They call it instant store. Instant store is basically the storage that you get along with your EC2 instance. For example, if I launch a server, there is a storage that attached to the instance by default, or some of the instances, older instances have it. From new ones doesn't support instant store anymore. We'll cover those in the tracks, but instance store is basically it's attached to the instance. If you lose an instance, if you destroy, if you stop it, you're losing all the data on it, right? Basically, it's an immutable thing, right? I mean, for example, EC2, the compute and RAM, they're pretty much stateless, right? You're not storing any important data. But if you're running a database and if you're using instance store, all the data on the database that's sitting on the instance store is not reliable, because EC2 failures are common and they will happen, and they will take care of it for you, but they won't guarantee the data stability or reliability, because the instance store storage options are not for that, but it's for the faster access and much cheaper price. The next is the EBS, right? EBS is basically elastic block storage. EBS is, you can have features. You can actually go from 100 gig to 1 terabyte just with one single click or a couple of API calls, right? And they expand it for you in real time seamlessly in the backend. You don't have to worry about it. I think even before this feature, it used to be different, but now the main difference between instance store and EBS is you can have your data even though your EC2 instance is gone. For example, if I create an EC2 instance and attach an EBS volume to it, I can just kill or destroy my EC2 instance, which means I'm not paying anymore for my EC2. Still is there, and I'm still paying for that EBS volume, which means you can take this volume, you take this drive, attach to any other EC2 instance. Right? If I have to bring up my backup database using this EBS, I will just detach the volume and attach it on a different EC2 instance, which could be bigger or smaller, right? So no data migrations. In a previous, in a more traditional world, you have to copy all this data from one server to another server, which has much bigger volume, right? You don't have to anymore. So EBS volumes are, there's a data consistency. They guarantee all the data reliability. You can even have snapshots on top of it. So it's much better option. Now, most of their latest EC2 instance types only support EBS. They don't want to, there's actually stop supporting the instance store. And there is S3, which is storage layer. This is not at the EC2 instance layer. This is a storage as a service, basically, right? This has nothing to do with EC2. You can, if you have just bunch of files that you want to store, you can just store it in S3 and use it in whatever way you want. And the way that it works with EC2 is if any of your application has much bigger data needs, you can just put it on S3 and then store it there. And S3 are different types, and I want to get it there, right? There's tier 1, tier 2, and there's Glacier and all those things, and we'll talk about it in the S3 videos. But S3 is basically a storage service, and the beauty of S3 is I think you can just put million nines as an SLA. The failure is really low. I mean, I could say 0, right? There's no data loss. They have never lost a single file so far. There's no data loss. There's no failures reported on S3 yet. So very reliable storage solution. And the next one is networking. The lot of different ways. And now networking is a much bigger concept in Amazon with their VPC, which is virtual private computing, connectivity. So the VPC, the subnets, there's a lot of this bigger one, which I'm not covering right now because it also falls under security. And we'll have a separate session for VPC in our videos. But in networking, basically, there's elastic IPs. And the concept of elastic is there everywhere, right? There's an IP that you can attach to one instance, and you can, if you want to move around, you can just take it from one to another, right? Today, one of my server has an elastic IP attached to it, and if I can just get rid of the EC2 instance and use the same IP, I can preserve that IP. Because usually, let me just take a step back. Usually on Amazon, when you launch EC2 instances, the IPs are dynamically allocated to them, which means they don't guarantee the same IP being allocated for the same instance again, unless you use elastic IPs. And most of your applications doesn't need an elastic IP, like permanent IP, but there's some that do require a doesn't like to have an IP changed every time you upgrade or every time you stop and start an instance. So which is where the elastic IPs will help you, because even if you stop and start, you can reattach the same elastic IP to it. So elastic IPs are something that you have to pay for in addition, but you can preserve them, and they are for you to use in whatever way you want. The static IPs and as well as private IPs, it's basically the dynamic IPs that we just talked about, and private IPs are not exposed to the public. These are all for internal networks, like from one EC to another EC2, from one subnet to another subnet. If you're talking from one EC2 to another EC2, there's a private IP address that they use to communicate, and there's a public IP address that's exposed to the public, and you can control that using security groups and everything. We'll talk about it. Don't get confused today. But there's public IPs and private IPs too, right? And they will change whenever you stop and start an instance or whenever you launch a new instance. They are not guaranteed to be the same. The last one is security, and there is a concept of firewalls. There's actually a lot that they introduced very recently. There's a product called Shield, all that stuff that we'll cover in the security sessions. But the basic ones, which is the building blocks for security for all these years, is basically the security groups. The concept is very, it could get complex, but let me just try to make it short. It's the control which IP people to connect to my server on 22, which means you're only allowing the SSH access, right? You can block every other port, right? Anybody that tries to access your server on any other port, they cannot access it. You can only expose certain ports to certain IPs or to certain servers. Let's say if I have a database server and I don't want anybody outside and it runs on port 3300, right? I want only my application servers or my internal application servers to talk to database, not anybody else. So you can have a security group that tells that only allow connections to port 330, a database port, from only these IPs or these security groups, right? So it's basically allowing you to secure your network connectivity within your EC2 or connectivity from outside to your infrastructure. So we'll cover a lot more details in the security groups track. Similarly, there are firewalls, and there's a bigger concept called VPC, which is the mix between networking and security. So that's pretty much it on the AWS side. And there are many more. There's DNS surveys, the CloudFront, which is CDN, the caching layer on top. And there are elastic load balancers. There's a lot more in it, and we will cover as I think as we make some progress on the courses tracks. And a couple more that I want to just reiterate. Right, we talked about AWS CLI already, and there's basically the console. Right, you can always do all these things that we just talked about by logging into Amazon console. Very easy. You can just log into their console. With a few clicks, you can launch servers, you can kill them, you can create a DNS, you can upload files to S3. You can do pretty much everything from their console. The only problem is it's not scalable, right? If you have to do 10 different things, you have to actually do it manually by clicking different buttons, versus running one script that can run 10 different commands at the same time in parallel. So that's the only difference. But I think the beauty of it is basically you don't need any programming language or any other command line tools to interact with Amazon. You can just log in from the dashboard, from the console. You can do pretty much everything. And okay, so let's get to the free tier, which is important for everyone to practice what we're going to talk in next videos. So free tier is a concept where everyone now has a different naming for it, but basically allows every user account to have some limits, some free tier limits for all of their solutions. For example, if you're looking at my screen, there's a 750 hours of Amazon EC2 compute in the free tier per month, right? I think it's 12 months in total. After 12 months, everything will be, you will get charged for all this. But within 12 months, what does it mean is, so everything on Amazon is per hour, right? Right. If you run instance for 5 minutes, and if you shut it down after at 6th minute, you're still getting charged for the whole hour, right? If you're running for 61 minutes, you're getting charged for 2 hours, right? So everything is billed per hour. And there's this advantage and disadvantage with it, but we don't talk about it right now. But here in free tier, what it means is, but it's a T2 micro instance, I guess. Yeah, so it's called T2 micro. You can actually Google it for T2 micro, and you will see what does it mean. I think it's 1 gig of RAM. They might have changed it, but that's the instance size that you can get. Every instance size that they offer has a name in Amazon and in any other cloud provider. So you can get 750 hours of T2 micro per month from Amazon for free, right? Which means I can run one T2 micro. 750 hours is basically one. That's it. So I can run one T2 micro for free for complete month, or I can run, let's say, do a different math. I can run 24 T2 micros. So let's say I can just launch 750 T2 micros for 1 hour, and then I just used up all my limit. So it's basically a number of hours, right? Let's say if I can run 75 of my T2 micro for the hours, and I can just consume my hours in a day or in a 2, and then I'm done with my limits. So basically, once you hit that limit, everything that you use after that, you have to pay for it. So you just have to be, careful about how much you use. There's a ways to manage your to monitor your resource usages, any estimated billings and all those things, and we'll try to cover some of those in the demo sessions later. But it's in hours, not in the number of instances, right? It's number of hours that you use. Same thing for S3. They'll give you 5 GB of standard storage on S3, which means you can store up to 5 GB for free. Anything after that, you have to pay for it. Amazon RDS is the database, relational database as a service, and they have the same thing, right? 750 hours of database. And there's a Lambda, which I don't want to talk about it right now, but it's also a different compute as a service now. They have 1 million free requests per month, and don't worry about it if you're not familiar with Lambda. We will cover that later. So similarly, right, they have, if you actually look at free tier, they have different limits for all of their services, and I'm sure, this is more than enough for us to practice and get familiar with AWS, and we'll use this free tier for most of our labs while we practice the Amazon from the console or from CLI. And there are some precautions that we need to make sure that, because we might just end up paying Amazon if we don't keep a close eye on how much we are using up. So that's pretty much it. That's the agenda for today, and let me see if there are any questions to answer. What is it? Any questions? Okay, a question from Prasad. If you have big data background, what AWS certification should we do? It's completely different though. So let's, I want to just decouple big data from AWS completely, but your background will help you in a different way. For example, you have to think about what you want to do in your career. For example, let's say you have said you've big data admin and dev experience. So this is a similar concept between that and Amazon, right? And even Amazon, if you have a development experience, you can also be an admin on Amazon, because I think you can pretty much manage Amazon with the programming knowledge, right? It's more developer friendly than anything else. So what, it depends on what you want to be. I I wouldn't suggest you to just focus on one, because there is this DevOps stream, and there is a developer stream, and there's this sysadmin stream, right? And for 3 different audiences completely. And there's an architect certification, which is both professional and beginner, which actually is a mix of both of this, right? You are in a much better stage at that. So if you want to be an AWS admin or development, I would say just don't focus on sysadmin or dev. If you are looking at DevOps as a career, then do more AWS DevOps certification. Is basically, if you are completely from sysadmin background, you can do that. But otherwise, if you are from admin and development background, you just pick the DevOps or the developer certification. And anything on your big data knowledge will probably not going to help you in the AWS certifications, but your administration knowledge and the development knowledge with dealing the distributed systems and all that will probably help you in the certifications, but definitely not big data. But there are certain pieces in Amazon, right, like EMR, the Redshift, and all those big data pieces. I think there you can apply your knowledge to get the certifications, or to use some of those services, but not in those certifications. Moving on to other question, what is the difference between solution architect? The question is basically, what is the difference between the solution architect, associate, and professional, and which one will give a broader knowledge? So basically, right, if you are already an architect and you want to get into cloud and everything, so basically the associate one is not for you, right? But let's say if you are in this administration, you probably are familiar with some of this architecture already, you want to get into this architect field. Advanced might be a last step, but I think the associate will be the first step, right? You get into architect level associate, just get a taste of it. You'll understand all the basic things that you need, because the professional one will definitely require some of the real-time experience too. It will definitely help. You can get certified, but to be more practical, associate will give you that entry point to get that knowledge to become more professional, right? So it's definitely based on the level where you are at. If you are getting started towards that stream, and based on the associate track, and based on your work experience, you can plan for the later. And I think the answer might change based on what stage of your career at, and we can take that as a separate thing. So that's a question from Venkat and Praveen. So I hope I answered the question. If not, just follow up with me at Durga, and we'll help you there. And just one more question. Moni Raja, thanks for the excellent start, of course, and again, apologies for all the initial delays and all the technical glitches that we had. This is my first time, so I promise I will get better at this. And most of the times, from next sessions, I think we'll avoid these problems. And I promise that we are building great quality content. I'm sure you guys will learn a lot from it. So the question is, we have AWS SDKs written in Java, Net, Python, which is most used in industry or projects. Basically, if I have to pick one, I personally pick Python, and it's just because it's very widely used. So I'll tell you, just I would take just one more minute to just answer this question. I've started using Amazon as primarily the developers, right? And most of the companies have Python already being used as a primary language for different purposes. and they want to just move their infrastructure onto cloud. They don't want to pick or they don't want to choose one more language. So people that are familiar with Python will just use Python and got it. And Python has already been most widely used programming language. And Ruby is actually catching up, but still Ruby has some issues. Python is more cleaner. People like Python a lot. And companies like Google and all these big companies has been a very early adopters of Python, and they there's a big push, a strong push on Python. Just a lot of people are familiar with Python, and it's just a popular language. That's it. And Java is, of course, yes. Java is much popular language, but I've seen very less in the AWS space where I've seen very less people using Java to interact with Amazon. It's been most of this one of these tools like Ruby or Python that I've seen mostly, but Java is because most popular language on the programming and developer side. Amazon is supporting Java natively, so that they can allow people to talk to Amazon by using one of the Java SDKs. So that's it. And I hope I answered the question. So that's pretty much for it. Again, if you guys have any, I know we are out of the time, so if you guys have any follow-up questions, post it on our blog below the cloud blog post that we have, and we will get back to you, and we'll keep you guys updated on the cloud tracks that we're building pretty soon. So I hope you guys enjoyed the session today, and thank you all for your time. So one more thing that forgot to tell is basically, please do fill the form that we have. We have it on the blog post, I guess. I think so. If you fill that form that you see it on our website, we will continuously, keep you guys posted on the progress that we're gonna make. Every time we upload a new content, every time we create a new playlist or a stream, you guys will get notified right away, and then you don't have to wait to get started. So right here, if you guys are actually looking at the screen, at the end of the blog post on the itversity.com, at the very end, there's subscribe here for itversity's cloud updates. So fill in your email address, your name, and hit subscribe, and you will get notified right away whenever we upload new content. That's pretty much it. All right, guys. Again, thank you everyone for your time. I think let's wait for the cloud content to come in, and yes, there's just more coming on your way. I'll talk to you guys later. That's it for today.